Lesson 7-7, Polar Coordinates. So here's the big question. So far in this chapter, we've used rectangular coordinates to graph circular and curved things. Why not use circles to graph circles? So that gave us the idea of polar coordinates, which are r theta. You could think of r as the radius and theta as the angle. So it's a radius and angle. If you look at the graph, we have the polar axis, which is the positive x-axis. And we have all these circles. So it's the angle in standard position and the radius out from the center. And the center we call the pole now. So it's actually easiest to graph by graphing the angle first and then going out the distance of the radius. So r is the distance from the pole. Theta is the angle counterclockwise from the polar axis. So the point 3 is square root of 3. The angle is square root of 3, which are usually labeled. And it's the third ring out. So it's r theta. Let's graph some points. Let's start with 4 pi over 4. So we find our angle pi over 4, and we want the fourth ring. Let's try negative 5, 2 pi over 3. So here's the 2 pi over 3, and I want the negative fifth ring. What's that mean? That means instead of going out that angle, you go the opposite direction. So there's 1, 2, 3, 4, 5. It's negative r, so we go the opposite direction. How about 3 negative pi over 6? Well, this time our angle is negative, so what we could do is we could add 2 pi, which would be 11 pi over 6 here, and we go 3 spaces out to get C. There are multiple ways to represent the same point, just like there's multiple ways to represent the same angle. We could add full circles to the angle, which brings us back around to where we were. Or we could go to the opposite side of the circle and add half a circle. So going to the opposite side of the circle, that's the minus r. And then add half a circle, that's what this business is. That gives you some odd, so like 1 pi or 3 pi or 5 pi, some odd number of pi's. Let's find 2 other ways to write 3 pi over 4. Well, one way is we could add 2 pi. We need a common denominator, of course. So that would be 9 pi over 4. That's one way. Or we could make our r negative and add 1 pi. Of course, we need a common denominator. So negative 3 and 5 pi over 4. Or we could add 4 pi or subtract 2 pi or all kinds of things. It is possible to convert between polar coordinates and regular coordinates, the xy coordinates. If we're in polar, as you can see there, we can draw a right triangle. Since it's a right triangle, we know r, since we're in polar, we know the theta and the r. X would be the adjacent side of the triangle, and r is the hypotenuse, which means we can use cosine. X would equal r cosine. Likewise, the y would be r sine theta. However, if we know the x and the y, to find r, just use the Pythagorean theorem, and the angle can be found using tangent. So let's convert 4 pi over 6 to rectangular coordinates. All right, so it's polar, so we're going to rectangular. So x equals r cosine theta. So that'll be 4 cosine of pi over 6. Cosine of pi over 6 is square root of 3 over 2. So that would be 2 times the square root of 3. Y is r sine theta. So 4 sine pi over 6. Sine of pi over 6 is a half. 4 times a half is 2. So it looks like my coordinate is 2 square root of 3, comma 2. Let's try going the other direction. Let's convert negative 1, 0 to polar coordinates. We can infer then that it's already in rectangular and that this is x and y. So then r is the square root of x squared plus y squared. So r is 1. And we can use inverse tangent to find the angle. So we have 0 over negative 1. So I have to decide when is tangent 0. Since tangent is y over x, where's the y value 0 is either here or there. Now which one is it? If we look at our polar coordinate, our rectangular coordinate, the negative 1, 0, it's right there. That angle is pi. So it's r theta. We can also convert equations using the same substitutions. Well, we had one that said r is the square root of x squared plus y squared. So we can substitute that for r. So we replace the r with x squared plus y squared, square root of that. Maybe we could square both sides to get x squared plus y squared equals 1, which would be a circle with a radius of 1. Well, how about this one? Let's see. Well, I want the x and y, so maybe we could use the tangent of theta equals y over x. So we can put in our pi over 4 for theta. So it's 1 equals y over x. So I get x equals y or y equals x, which is a line. Let's convert r equals cosecant theta. Well, that's interesting. Well, cosecant is 1 over sine. I can multiply both sides by sine theta to get that. Oh wait, r sine theta is y. So this is just y equals 1, which is a horizontal line.